Hello there and welcome to question 5 from revision sheet 1. So here we have a 3 by 3 matrix A, 5A, 4B minus 7, 8, 2 minus 2C. And the question is given that A minus 1, or the inverse of A, is equal to A, so it's a self-inverting matrix, the inverse is itself. Find the values of the constants A, B and C. And we've got an extra hint here to consider what we'd get when we times A minus 1, or inverse A, by A. Now I know from my definitions of multiplying an inverse matrix by a matrix, I get the identity. So I know what this matrix is going to be. And I can also consider the fact that the inverse matrix is the matrix A itself. So in this little hint here, I'm going to replace the A inverse with the matrix A, keep that matrix A in there, and this is the strategy I'm going to be using for this question here. I'm going to multiply the matrix A by itself, and then compare each of those 9 cells with the 9 cells that appear in the I3 matrix. 1 0 0 0 1 0 0 0 1. So let's get started. It's going to be quite a long question, lots of places to trip up, so make sure you double check your answer at the end, and you can obviously do that using your calculator. Okay, so let's get started. The way we multiply matrices is we work with the rows on the first matrix and multiply them by the columns on the second matrix. So in this case here, I'm going to be working along through 5A and 4 for the top cell, and 5B2 for the left-hand cell, and I'll get the top left-hand cell as my answer. So let's have a go. 5 times 5 is 25. Working across the first matrix here to the A, and down the first column here to the B. So it's going to be A times B, which is plus AB. And in the third cell here, working rightwards across this row here, I get a 4, and working down the column here, I get to a 2. So I get plus 8. So my first top left-hand cell is this expression here. Let's finish the rest of them. 5 times A is 5A. Working across here and down this column here. A times minus 7 is minus 7A. And 4 times minus 2 is minus 8. Next one. 5 times 4 is 20. A times 8 is plus 8A, and 4 times C is plus 4C. So that's the top row of my matrix complete. Next we'll work through the middle row and each of the 3 columns. So starting off, 5 times B is 5B, minus 7 times B is minus 7B, and 8 times 2 is 16. Middle this time. A times B is AB. Minus 7 times minus 7 is plus 49. And 8 times minus 2 is minus 16. Working on the middle right hand cell now. B times 4 is 4B. Minus 7 times 8 is minus 56, and 8 times C is 8C. Okay, so final row here now. 2 times 5 is 10, minus 2 times B is minus 2B, and C times 2 is plus 2C. 2 times A is 2A. Minus 2 times minus 7 is plus 14, and c times minus 2 is minus 2c. The final one, 2 times 4 is 8, minus 2 times 8 is minus 16, and c times c is plus c squared. And what I'm going to be comparing this to is, I've multiplied a times a, that's this big matrix here. I'm now going to be comparing it with the I3 matrix, and that goes 1, 0, 0, 0, 1, 0, 0, 0, 1. So what I'm going to look to make life easy for myself, I'm going to compare cells where there are only one letter in there. That way I won't have to use simultaneous equations. This middle top cell looks quite useful to me. It's only got A's in it, and I'll compare the middle top cell here with the middle top cell in the identity matrix. So working with the top middle, I'm going to get minus 2a minus 8 from the top middle cell in the first matrix will equal 0 as the top middle cell in the identity matrix. And from here I can clearly see that minus 2a, or 2a will have to equal minus 8, so a will have to equal minus 4. Now working with the middle left hand cell, I've chosen the middle left hand cell because it has only b's in it. The total expression is minus 2b plus 16 will equal the middle left cell in the identity matrix, 0. So I get another equals 0. And looking to solve this, add the 2b to the side, divide by the 2, I get b is 8. Now, for c, the only cell I can see that only has a c in it is this cell in the bottom right hand side. It has a c squared in it though, which is very annoying, because therefore c could either be a positive or a negative value, and I'm pretty sure it's only going to be either the positive or the negative value. So instead of using this bottom right hand cell, I'm going to use a different cell and use my answer for either a or b to help me out. Let's just use the bottom middle one, this one here, bottom middle. I could have done this with probably any other cell in the matrix. So minus 2 times a was minus 4, so I'm going to get a minus 8 here. Add on the 14 and take away 2c. And that will equal the same cell in the identity matrix. Bottom middle is a 0, so I'll use my 0 there. So from here I can work out that 2c is going to equal 6, so c is going to equal 3. So the answers here are a equals minus 4, b equals 8, and c equals 3. 5 marks.